So good evening to all. So basically, I will just give an overview of what we plan in this session. So basically, one of the most important topics that we need throughout our data science journey is probability, because it is whatever we are doing in machine learning or data science application analytics, everything is based on chance only. So probability is like the mathematical basis which describes chance, helps us to find out how to use that, how to define whether something will happen, or how to see if whether something is what we want, or something which will happen is not something that we want, things like that. So this is like some foundations that you need to have strong for your learning data science related subjects. So we will delve slightly into detail. So basically we will be covering what we learned in +2 only, but it may be maybe 10 years back for me, 2 years back for someone else, 5 years back for someone else. So we will just do like a brainstorming. We will just review whatever we learned in the theory concepts first, and then we will see some examples and see whether we are able to apply whatever concepts we saw. Then one thing that will differ is like in our +2 courses, we would have focused more on like textual descriptions, but I will go slightly only mathematical way in line with set notation and all, which I will introduce shortly, so that we will like bridge the gap between whatever we learned in +2 and whatever we will learn forward in our data science topics. So basically, this will be my outline. So my reference will be the NCERT Max textbooks for standard 11 and 12 mostly, and we will be covering sets, permutation and combinations, probability. These are like in standard 11 topics currently, and probability distributions. I'll be covering standard 12 topics plus additional topics. So we will cover the first 3 in this session: sets, permutation, combination, and probability. And probability distributions we will discuss next week. Okay, all set. Okay, so we will start with sets, because sets is something that we all know. We might have used it even when you learn Python, you will have implemented sets. So but that time we did not go into the max behind what is a set, or what are the definitions or keywords or terms associated with a set. So we will just briefly touch upon that. So actually sets form the foundation of relations and functions, sequences, geometry, probability theory. That is, many areas of the mathematics as we know today are fundamentally based on the concept of sets. And what is a set? A set is a well-defined collection of objects. So if I have a set of animals, so that is well defined. It will contain only animals, right? It will not contain any bird, or it will not contain any what other thing, anything like a pen, paper. Those are not animals. So that is like what we mean by well-defined collection of objects. Now then sets are usually denoted by uppercase letters A, B, C, S, omega, Greek letters also, whatever it is. And the elements of a set are usually denoted by lowercase letters like A, B, C, and all. And the smaller letters of Greek also, omega, alpha, that kind of thing. And if A is an element of a set A, we say that A belongs to A. Like lion is a belongs to a set of animals, right? So that is the operator which is used to denote such a like belongs to thing is called epsilon, Greek letter small letter epsilon. So it is used to denote that the element small a belongs to the set capital. And similarly, for not belonging to a particular set, we will denote it as epsilon with a cross sign. So that will tell me that this is not an element of some particular set. And now there are a variety of sets that we encounter in mathematics. Like all these things, you know, set of all natural numbers. So we will just denote what it is, how is it represented in when you go through any mathematical document or terms and all. So there are some letters which are usually used to denote these set of all natural numbers 1, 2, 3, 4 up to infinity, right? So that is denoted by n. Set of all integers minus infinity to plus infinity, including positive, negative, 0. So that is denoted by set. So if you want positive integers alone, you will use a notation like set plus. And Q is a set of all rational numbers 1.5, 2.5, 3.5. Right. And Q plus similarly for positive. And T denotes a set of all irrational numbers like 1 by 3, 2 by 3. You can denote it only 1 by 3 by 0.333, infinite number of 3s, right? So those kind of things are irrational. Then R is a set of real numbers which consists of all the rational elements as well as all the irrational elements. Similarly, R plus for positive. And C is like the most comprehensive thing, which includes all the complex numbers. Now, when we go further into machine learning, data science and all, we will introduce like multiple dimensions, tensors and all. So that will again build upon all these sets. So these are some of the basic sets that we are concerned about when we are discussing about mathematics. So now some different types of sets we can see. An empty set, null set, or a void set. So it is basically a set which does not contain any elements. So what is it used for? Suppose I am trying to create a set. So I will initially have nothing in it, and then I will try to add elements to the set one by one. Like you can correlate with our Python examples where we want to selectively add elements to a set. So the first thing that I will do is I will create an empty set and I will add on elements to it. So that is the initialization part. And when we are discussing a probability and all, some events which will never occur, if we check for the occurrence of that will be corresponding to a null set. Like if I cause a toy, I will get a head or a tail. So if I want to have a set which will not contain any element, which will be an outcome of a toss of a coin, that will be an empty set, right? Because I am sure that either head or tail will come. Then finite and infinite sets. So finite set is a set for which we know how many elements are there. So suppose I have a set of the first 100 natural numbers. So I know that it contains 100 elements. Whereas infinite set is something for which I don't know the size. Suppose I tell that what we saw earlier, a set of natural numbers. So it goes from 1 to infinity. So I don't know the actual length of the set. So such type of sets we will denote it as infinite sets. And then equal sets. So when are two sets assumed to be equal? So two sets are said to be equal if they have exactly the same elements. So if a set A and set B has like 5 elements and each of the 5 elements in set 1 are there in set B, then we will call that two sets are equal. So otherwise the sets are said to be not equal and we write as not equal to with symbol. And similarly, there is a concept called equivalent sets. So what is the difference between equal and equivalent is that two finite sets A and B are said to be equivalent. As you can see, equal sets as well as equivalent sets. Equal sets we can denote for infinite also, because suppose I have a natural numbers and I have a set corresponding to positive integers, then both will be same only, right? So that way I can tell that set plus is equal to n. But equivalent sets, the difference is I have specifically mentioned here that it is applicable only for finite sets. I will tell why. Because two finite sets are said to be equivalent if they have the same number of elements. And this symbol you see, either we will use a double-ended arrow, or sometimes you can use like equal to with the 2 tildes. In some documentation you can see like that. So both these will tell that two sets are equivalent. For example, 1, 2, 3, 4, 5 is a first set. Small letter A, B, C, D is second set. So these are equivalent, but not equal, right? So the concept of equivalent is how it is important is that suppose I am doing some machine learning algorithm or something, and I have like one set of outcomes corresponding to numerical values, another set of outcomes corresponding to this like characters. Then I want to like map it, and I want to tell that okay, this 5 elements and this 5 elements I should be able to compare in some way. So that kind of applications we will go for. The application of the we will need to check whether the sets are equivalent or not. And then the next concept in set is called a subset. This already you might be familiar, but I will just tell what it is, what's the definition and all. So okay, a set A is said to be a subset of set B if every element of A is also an element of B. So suppose I have a big set B which contains 10 elements, and I have a small set A which contains maybe 5 elements which are present in B. Then we will tell that A is a subset of B. And we will denote it with a notation like this. And it is written mathematically, it will be similar to the second line. A is a subset of B if for every element, a small a element of capital A, it is that element small a is present in capital B set as well. So this is how we denote mathematically. If we go one more level, we will use a symbol something like this, which will denote that for all. So that will be the like fully mathematical description of this. We will write A is a subset of B if something instead of this for all which I have written in words here, that will be replaced by this symbol. That will be like the full mathematical representation of a subset. And this some things are as a corollary to this definition is every set A is a subset of itself. We will tell that A is a subset of itself. So that if it is like that, we will call that if the subset that we are referring to is the set itself, then we will call such a subset as an improper subset of A. And since the empty set null set or that we saw phi that we saw earlier has no elements, which can also be considered as a subset of every set. So whatever set you consider, if you consider a subset without any elements, that will also be a subset of the actual set. And if A is a subset of B and A not equal to B, that is like we saw in this condition that corresponding to set of A. So if it is not equal to this condition, the opposite of this condition, whatever subsets that are not part of that, we will consider it as a proper subset. So this thing we will call as an improper subset, and everything else we will call as a proper subset, that is including the null set. And proper subset of A include all subset of A including phi except the improper subset. And if a set has n elements, we can tell that the total number of subsets is 2 raised to n. That is including the improper subset. So if I want the number of proper subsets, that will be 2 raised to n minus 1. So like that, if we relating to our mathematical example that we saw just now, we can see that natural numbers are a subset of integers, which are a subset of real numbers, subset of rational numbers, and rational numbers are a subset of real numbers. The rational numbers are a subset of real numbers, but natural numbers are not a subset of irrational numbers. So like that, the definitions we can define between different types of sets. Now, what is a power set? The set of all subsets of a set A is called the power set. Now, where we will this will come into picture is suppose when we are seeing probability based on outcomes, then we may need to write out what are the outcomes corresponding to total number of outcomes that I can accept. So that kind of things, this concept of power set comes into picture. So this includes a improper subset as well as all the proper subsets. So if you get any doubts or you want me to explain something in more detail, you can always use the chat window. Okay, so this is the last set on sets, last slide on sets. So what is a universal set? So usually in a particular context, we have to deal with elements and subsets of a basic set. So that basic set of the problem which we are considering currently, that is called a universal set, and it is denoted by U, and its subsets are denoted by other letters A, B, C, S, omega, like that. For example, if you are considering something like human population studies, like the set of humans who are vaccinated, or the set of humans who got COVID, or who got cured from COVID, or who are yet to get COVID, things like that in human population studies, the universal set, we can tell that it is the set consisting of all the people in the world. So, okay, I need answers on chat. So if I consider the set, which is the human population studies universal set consisting of all the people in the world, is it an infinite set or a finite set? Can I get some answers? The universal set, yeah, right, Prashant. It is a finite set. Why it is? Because even though it may be difficult to count the total number of people in world, we know that it will be like 700 crore or 800 crore. Whatever it is actually a finite quantity. It is not like we will have keep on that, because our resources in the world are limited at any moment of time. Even if you are considering the problem after some 10 years, 100 years, 50 years, 1000 years, since even the full universe and the resources are limited, so the set of population will be always finite. It may be a very large number. It may be like running into tens of hundreds of digits after maybe 100 years, but that will still be a finite set only. But whereas earlier, like we saw the set of integers, a set of natural numbers, those kind of things are infinite sets, because I don't know where that set ends. And then we will just see what are the operations on sets. I will not delve into details. I will just tell what it is, because we will see these subsequently. So union of sets is a set which consists of elements which are present in both sets. Intersection of sets and whatever it is denoted by union is by U, intersection by an inverted U, that consists of elements which are common to both sets alone. And a set difference is A minus B, and that is like will give you the elements of A which are not present in B. Suppose A has some 10 elements, B has some 20 elements, and 3 elements from A are there in set B also. Then if I do a set difference operation, that A will contain the remaining 10 minus 3, 7 values alone in my set difference. And symmetric difference is like A delta B. And sometimes in programming and all, we will use XOR, A XOR B. So that will give me like A minus B union B minus A. So that means it will give remove the, it will do a union of A and B, and then it will remove the elements which are common to both A and B. So this will be this can be also written as A union B minus A intersection B. That is also a valid description for the symmetric difference.